So we're going to sketch this trigonometric function a really quick way using this grid. So the first thing we've got here is that the amplitude is equal to 2 and the period is equal to 2 pi over 2, which is equal to pi. And that's really important. And we also know that we've got a domain of negative pi to pi. So we may as well use that grid to work that out. We're going to go from pi to negative pi. We can count there's 12 grid lines here. So really we're between 0 and pi, so halfway is going to be pi and 2 over here. And we've got a period of pi. What that means is that we're going to have a little sine shape between not 0 and 2 pi, but 0 and pi. So let's start. This is going to be halfway, 3/4, a quarter of the way. And we can actually label those. So there's pi and 2, 3 pi and 4, pi and 4. We may as well do it on this side as well. There's negative pi and 2, negative pi and 4, negative 3 pi on 4. So we're going to use that and this shape to sketch this graph. So a equals 2, and we have a mean value of minus 2 there, which means that our maximum is going to be negative 2 plus 2, 0, and our min is negative 2 minus 2, which is negative 4. And we can draw those in. So here's our negative 4, we'll make that negative 2, that's our mean line, and we've got our maximum line there, 0. So we can start putting in our key points, the key points that we get from our sine graph. The first key point is going to be here, and the end point, our middle point, our maximum, and our minimum. So you can see our basic sine shape there. We can go back this way too. And so there's our basic sine graph based on our amplitude, our period, and our shift. However, we've also got a shift of pi and 4 to the right. And pi and 4 in this case is 1, 2, 3 grid lines. So we're going to shift 3 grid lines to the right. Let's do that with all these points. So I go shift to there, this one will shift to there, this one will shift to there, this one will shift to there. Let's go over here as well, shifting 3 places, 3 places, shift 3 places, shift 3 places. Even this one here, it sort of goes past the graph. We know 3 places back is going to be the other minimum there. And so we've got all these crosses and we can just join them up. And there's our graph pretty much finished. It says to label the intercepts, but we know what these are. That's pi and it's negative 4. This is negative pi, negative 4. That's going to be negative pi onto 0, labeling it as coordinates. Last one is the y-intercept, so that's 0, negative 4. And so that's finished there, and that's the whole 3 marks. Not much working out is necessary, but the key here is to use the grid and the amplitude and the period. So here's another circular functions graph that we can sketch using the grid. So we'll state the amplitude and the period. Amplitude is 1, period equals 2 pi over 2, which equals pi. So on a normal sine graph, we have points at 0 and pi and a quarter. It's a quarter, pi and 2, and 3 pi and 4. We have those 5 key points at a quarter of the period. And we're going to use that idea. We have a maximum at 1 because the amplitude is simply 1, and the minimum at negative 1. So let's put those in. We've got 1 there, negative 1 there. So let's use this idea. We have pi and minus pi on the grid already. So halfway along, this is divided up into 12s. So halfway along is 6. 1, 2, 3, 4, 5, 6. So there's a quarter there as well. What that means is that our key points are going to be like that. So we'll have that basic sine graph. We can do that on the other side as well. So we got our key points here, here, quarter of the way. So that would be our basic sine graph without this horizontal shift. Now we've got to work out what this horizontal shift is. It's pi on 3. And pi on 3 on a scale of 12s, that's going to be pi on 12, 2 pi on 12, 3 pi on 12, 4 pi on 12. 4 pi on 12 is pi on 3. So it's really 4 places across will be how much we shift pi on 3. So each of these dots will shift 4 places to the right. 1, 2, 3, 4. 1, 2, 3, 4. That goes over there. This is going to go off our minus pi to pi scale, but that's okay. That will go over to there. This point will go 1, 2, 3, 4. 1, 2, 3, 4 there. 1, 2, 3, 4 across to there. 1, 2, 3, 4. So we've kind of got our basic shape going already. This, which goes off the scale to about there, kind of tells us that we're going to have a graph going through that point and up through here, through there, through a y-intercept and back down. Of course here it's going to go like this, and we know where that point is going to be because if you have a look here, there's 1, 2, 3 places between the intercept and the maximum. So really this intercept is going to be down here, 1, 2, 3 places. Not that intercept, the minimum. We'll have the intercept over here somewhere. We're not sure where that is, but we'll find out shortly. So we can go ahead and join this up. And that's basically our graph. But we need more than that because we need to label the intercepts as coordinates and the endpoints. So let's do the intercepts and intercepts first. We can see this is pi on 12, and so there's 4 pi on 12, which is really pi on 3. This here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi on 12. That's really 5 pi on 6. This one here is 2 pi on 12, which is pi on 6. It's negative. And we have 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 pi on 12. And 8 pi on 12, which is negative 2 pi on 3. So I can label that there. This point here and these points, there's really no way around this. We kind of have to work it out, but we can see that there's a symmetry here. So maybe if we just put in 0, that's 2, 0 minus pi on 3. That will be sine 2, negative 2 pi on 3. And sine of negative 2 pi on 3, if we use our unit circle, negative 2 pi on 3, here's pi on 3, there's negative 2 pi on 3 there. So that's going to give us a negative value. It's actually the same as negative sine of pi on 3. And sine of pi on 3, if we use our triangles to remember, sine pi on 3 is going to be root 3 on 2, so that's going to be negative root 3 on 2. So each of these points are on negative root 3 on 2. So that's pi negative root 3 on 2. That's 0, negative root 3 on 2. And that is negative pi, negative root 3 on 2. So I've now labelled my x-intercepts, answered the question, labelled the endpoints as coordinates as well, and I've got the y-intercept. So that's done.